everyone, welcome to part 2 of the webinar series covering CAD to Path features in RoboDK. I'm Lauren and I'm co-founder and marketing manager here at RoboDK. Before we get started, for those of you who don't know us already, RoboDK is simulation software for industrial robots. This means you can simulate industrial robot arms and generate robot programs in a user-friendly way. RoboDK allows you to generate robot programs for robot machining, pick and place, 3D printing, and more. It's a cost-effective way to generate error-free robot programs from your 3D models, avoiding singularities, access limits, and collisions. Everything we're going to cover in this webinar, which will begin shortly, can be done with the RoboDK Professional License. You can visit our website to download a trial, read our case studies, or contact us for more information. You can also find useful information on our blog and forum. If you've been browsing our online documentation or checking our YouTube channel, you probably already know Jeremy. Jeremy is product manager at RoboDK, and he'll be taking over from here to guide you through the webinar.
Hey, what's up guys? Jeremy here from RoboDK. Welcome to another offline programming webinar presenting RoboDK's feature. As Lauren just said, today we will continue exploring the CAD to Path features. But before jumping in the main topic, there's a few things that I would like to tell you. First of all, this webinar will be split in 2 parts. In the first part, I will do a classical technical demo, and in the second part, I will answer your technical questions. So if you have any technical questions, feel free to write them down in the chat at any moment. On the same topic, if you are following us right now on YouTube, be aware that the Q&A session will only be available on the webinar platform. So if you want to participate to the Q&A session, I added the link to the webinar platform in the description of this video, so you can switch platform whenever you want. Also, the replay of this webinar will be available as soon as we are done on our YouTube channel. You can already watch all the other webinars we did this year. And if you want to download the example I will be using today, will be available for you to download if you want to practice. I'll give you the link at the end of the webinar, so stick around. Okay, so that's pretty much everything I needed to tell you in terms of normal messages. Now I have a way more interesting message for you guys. We are all pretty lucky, so today, in addition to the normal technical demo I'll give you, I will also be able to present you some new features. So when I say new features, I'm really talking brand new. They were part of yesterday's release. So if you want to have access to them, go download the latest version of RoboDK directly on our website as soon as this webinar is over. Okay, so let's continue with the technical part. So first, a little recap from the first webinar. So the goal of any CAD to Path feature is to help us create robot programs directly from the 3D model of your part. We try to do that with a fast and user-friendly workflow. As we've seen, RoboDK includes many features to help you save time creating complex paths. So in the first webinar, we generally concentrated on the teach on surface, which gave us this, this example here. Can run this program. So this is an inspection project that we did in the first webinar. Super useful. You just click directly on the surface to create your targets or your points to reach. You're sure that you're always in the same orientation, either always normal, and you know that you are always at the same distance from the part. So this is super useful. But at some point, if you want to deal with programs that are projects that are a bit more complex, it can have some limitations. So let's say here we want to do some dispensing of a glue or sealant in this groove right here. It's possible to do that using the teach target on surface, but that can take quite a lot of time and not be super flexible and super fast. So this is one of the situation where the curve follow project, which is another curve to path feature that we have, is super useful. Here I have two curve follow projects, so one for each section. Same here in the canoe polishing. So some of you may recognize this example from our YouTube channel. So I've used this to showcase the Inventor plugin, pretty much just following the path here to polish the canoe. Here, some difficulty. We have some big orientation change and some singularity limitations. So RoboDK helps us avoid all of those automatically. Another place where curve follow projects can be very useful is when you do what we call remote TCP. So remote TCP are when the robot is holding the object and the actual tool is fixed to the station. So like this here, we are cutting, let's say, excess material from a molded part using a laser, and we simply drive our piece around the tool like that. So, and here we're using a curve follow project. So curve follow project can help you create standard program and robot holds object or remote TCP program also. So, okay, just before going with the real demo, I have a little slide real quick right here. So as I said, we have teach on surface, we have curve follow project, and we have machining project. All of those have their strength and if I can say, or their purpose. So the curve follow project is the teach on surface is really there for simple programs, simple application with just a small amount of points. The curve follow project is more versatile, so you can pretty much tackle any kind of difficulty. But at some point, if you want to do things like machining, 3D printing, deburring, things that are a bit more, let's say, have way more points, I would recommend you to go for a machining project instead. Okay, so back to the presentation. So I'll start with an empty station just to show you how you can add a curve follow project. So here in utilities, you have curve follow project. Like that, you will have this window. So we will tackle a good amount of those options and parameters right here. So this is like, let's say, the feature when you just open it with nothing in it. You can enter your robot reference frame tool. You can deal with approach and retract movement, the speed, the curve themselves, the orientation of the tool, what kind of algorithm you want to follow. So we'll talk about that later. And optimization parameter if you need to deal with singularities, joint limits, and stuff like that. Okay, so let's go for the first example here, which is this 5-axis dispensing project. So as you can see here, I have two curve follow project, one for each section here. And if I click on, sorry for that, bring back in the right orientation. If I click on select curve, you can see here that I'm following a curve that is right here. If I click done like that, and if I show this curve, visible, the other one, visible, I was following the black line that you can see right here. So first thing that I need to tell you how to do is exactly how to extract or import those paths. So if I jump to the next example, just bring the robot back to home. So this is a piece, a demo part with a lot of different curves, shapes, and stuff, really for a demo purposes. So let's say that I want to follow the top line right there. So inside RoboDK, we now have 3 different ways of extracting or importing the path. So either you extract it directly from the 3D model inside RoboDK, or you import it as a CSV or text file, so just a list of points to follow, or you use one of our CAD plugin to do so. So if we start with the first option, let's go here. Okay, so this is one of the new feature that I needed to show you. So here you have the create curves. Create curve, if you activate that, you'll see this little window here, and you can activate the auto extract curve. So if I click on that, every time I'll go near an edge, I'll have a blue line that appearing, and I'll also have small arrows appearing showing orientation, the extracted orientation for the tool. So let's say that I come here. You can see that if I move my mouse a bit, I have some different tilt possibilities. So here this is driven by the tilt step. So if I go, let's say, just for 15 instead of 45, if I come here, I have different option. Starting from here, tuk, 3 options to reach 45, 3 options to reach 45, in the other way around here. 3 options to reach 45 also. Now, oops, sorry, this is okay. It was not on purpose, but I created a line that I do not need, so I can just right click on it and delete curve and re-click auto extract curve. So let's just select this one. So if I want to make sure that I'm normal, I can simply enter a high value here and I'll be normal. So this is a brand new feature, is super useful for simple path, just like that. So now I have this path here. Let's say that I want this other one here, the one all along here, but I want to have a 45-degree angle between those two surfaces. So I can just come here, enter 45, and oops, and select my path. Oops, if I can just like grab it, obviously, like that. Okay. And I can click done, and here I have the first path and the second path. So now I could come here, utilities, curve follow project, select curve and select this curve here, update, and then simulate, and I'm following this path just like that. And 2 clicks later, I'm ready to send that to the actual robot controller. Okay, so this was the first method. And the newest method, it's super cool. They added a way to be able to tilt the curve. So this is like a great improvement. Now the second method uses, I'm just gonna delete, so delete all curve. The second method uses plain text or a CSV file. So you need to have a list of XYZ IGK, so unit vector, a list of points like that you will import, and it will create the actual curve inside RoboDK. So to have access to that, you can just click on Utilities, Import Curve. You go grab your curve. So in my case, I'll import the exact same curves as I just extracted automatically. So the one on top, just like that. As you can see here, it was created at the end of the station. So the curve is right, oops, there here, because for the moment it's positioned with respect to the origin of the station. But if I just drag and drop it in the reference frame I was working on, here now it's exactly where it's supposed to be. And I can do the exact same thing for the other 45-degree here curve. So this one here, again, it was imported right there with the normals that are at a 45-degree angle, 45 degrees angle. And just like that, I have both my path, and I can, again, utilities, curve follow project, select curve, just like that, and click done. By the way, so those list of points can be created in different ways. If you have, let's say you created yourself an algorithm in MATLAB or using any other programming language and you just want to follow those points, this is an option. Another way to create this list is just like if you extracted a curve using either the plugins or the auto extract, you can right click on the curve and export the curve. You will then be able to save it as a CSV file, exactly like this one. By the way, you need to remove the XYZ IGK here. I just added it so that you guys can better like understand which what is the role of each column here. Like that. Perfect. Okay, so third option would be to use our CAD plugin. So here, if I open SolidWorks, I have my part right there. So if you already had the CAD plugin, the CAD software installed on your computer when you installed RoboDK, the CAD plugin will be installed automatically. You just need to activate it. The CAD plugin lets you do too many things. Obviously, load part, you can load point, load curves. So you can either load edges, exactly like I did, or you can load sketches, so either 2D and 3D sketches. I'll do another webinar later on, especially on plugins, but I would just want to give you a small hint. So I could select exactly like I did before, just select the edges, but here I created a sketch that is following this dispensing path, let's say. So I can select that. So I click load curve, I'm gonna select this curve, sketch here. I'm going to select a surface. The goal of selecting a surface is to give RoboDK an orientation for the tool. It's going to be normal to that path, to that surface here. So if I click OK, go back to RoboDK, you can see that the path was imported at the right position, and I'm already ready to execute it. Just for simulation here, I could afterwards stop that, right click, generate the robot program. This window here will appear, and when the loading is done, I have the script file here for the UR robot ready to be sent to the robot controller with all the points. Okay, so those were the three methods to extract points. Just gonna go for a little pro tip. When you extract the path the curve directly from the 3D model of RoboDK, it will highly depend, the precision of the path will highly depend on the precision of the part. So some of you may not know, but there is a way to like simplify the parts when you import them in RoboDK. So if you just go tools and then options, if you go CAD, you can click here on fast import settings, default settings, or modify the settings by yourself. So if you go for the fast import setting, it will pretty much just take the curves of the curved surfaces of the part, and transform them into polygons, like you can see here. So those three parts were the exact same cylinder in the CAD software used, but they just didn't have the same parameters when they were imported inside RoboDK. So here it's with the fast import settings. You can see that when I extracted the path, the points are quite far from one another, so not super precise. I want to follow a real curve. So this is the normal setting. Here the result is obviously better. In here I went for a setting where my linear tolerances were my linear tolerance and angular tolerance were very, very low. So this way, when I extracted the path, it created a lot more points. So in theory, I should be able to follow this cylinder in a more precise way. Okay, so this was just a pro tip. Okay, cool. So now let's go for this dispensing example. So this is a 3-axis dispensing example. So we're only using XYZ. We're not like rotating, we're not changing the orientation of the tool in any way. So if I want to follow this path, so here I did things ahead of time to save a bit of time for the webinar. So I already imported the path, as you can see right here. So if I go Utilities, Curve Follow Project, when you create a curve follow project and you already have a robot, an activated reference frame, and a tool, it will automatically populate this here. So next thing to do is to select the curve. So I select the curve here, click select. I don't need to auto extract in this case because I already have the curve. So if I select it, you can see that first of all, the path became green, and you have a 1 and a 2 that appeared. It's pretty much showing you in which direction the path will be executed. So from point A to point 1 to point 2. And I can select the other section here from point 3 to point 4. That makes sense. And I can click done here. Now if I update, I can simulate. So it's following the path, but as you can see, the orientation of the tool is not exactly what I would prefer. I can use here the little scroll bar to see different points of the project. So if I click on show preferred toolpath here, you will see a bunch of ghost tools appearing. Those ghost tools represent the preferred orientation of the tool along the path. So if I want, I can just come here, Rod Z, so path to tool offset, use my scroll wheel, and then change the orientation of the path just like this. So let's say here 90 degrees like that. I can update, I can simulate, and now the path is following, the tool is following the path with a 90-degree angle like that. So this is great. This worked pretty fine. It was pretty quick. Okay, this is cool. But now let's say that I want to have the tool in the flange in the direction of the robot. So I showed you the first method to modify the orientation of the tool, but there's another method a bit more visual. So if I right click the tool, visible TCP, press Alt to be able to modify its position. So let's say that I want the tool to be in this orientation, something like that. I can just come here and click Teach. It will record this orientation and try to apply it to the whole program. So just like that, I was able to manage the orientation of the tool. Okay, so that's great. But now, so in this situation here, it's possible maybe to have the tool always pointing in the same direction. Some dispensing application will work this way. That all depends on the shape of the tip of your dispensing tool. But in certain situations, you need to have to follow the orientation of the path. So you need to, let's say, if you had like a taper tip here, you could say that I always need to have the taper tip pointing in the direction where I do not have any material. So I always need to like follow the path. So we have different algorithm built inside RoboDK. So by default, you will have the minimum tool orientation change. So this is exactly what we were doing here. But you also have the tool orientation follows path, robot holds object, and robot holds object and follows path. So those are the four options. Let's see. So I created a small example here to be able to show you the difference. So here, the first one is the minimum tool orientation change, so the default algorithm. As you can see, it's following the path as requested, but the TCP is not moving with respect to the path. It's always static with respect to the robot base reference frame. On the other hand here, if I launch the tool orientation change, it will really like follow the path along the way. As you can see, the x-axis is always pointing, is always tangent to the actual path. So I'm going to stop that. Here we have the two other options for the remote TCP. So as I explained before, remote TCP is when the robot is holding the object. I'll do a webinar on this subject also in the future. But here, first algorithm, we have robot holds object. So fairly simple. It's pretty much just a minimum tool orientation change, just like that. And you also have the so a robot holds object and follows path. So in this situation, we are working more with the actual wrist of the robot to execute the path. So here I could launch the 4 robots at the same time, just like that. So RoboDK is able to manage multiple applications at the same time in the same station, just like that. So minimum tool orientation change, tool orientation follows path, robot holds object, and follows path. Let's stop that, press escape. Next example, so we're back to the same example as before, but let's say that this time we want to use the tool orientation follows path. So if I open the curve follow project I have, I can click on select curve again, and I'm just going to select 1/2 of the path for the moment. And let's go for tool orientation follows path. So if I click update, it gives me a big red X. So robot cannot reach all target in the path. So this is unfortunate. And here, if I try to launch this, here, as you can see, I'm not able to go further than that. And the reason, if I double click on the robot, the reason being that joint 4 right now is has reached its limits, so it cannot go any further than that. So in a case like this, there's not really a way to do this path in one single shot. So what I can do is like split this path in 2 sections. So do this one, this half, this half, this half, and this half. So this is what we're gonna do. So just gonna go and hide this. I'm just gonna select curve. I'm just gonna reset selection so that I have nothing. Okay. So if you want to split the path, one cool thing that you can do, and it's a new feature also, you can right click on the path, split curve, and then split here. That will literally just create 2 pieces of the path. I can do again here. Interesting thing here, you have flip curve normals. So if you ever import your curves and normals and all the arrows are just pointing in the wrong direction, you can just click flip normals here and it should work. But I'm gonna go here again for split here. So again, 2 pieces of the same path. So bring the robot back to home. Open this here. I'm gonna go. Anyway, I'm gonna start by Control C, creating 3 copies of this. I'm gonna give them a different name. Oops. So this one will be. Oops. This I press F1. Sorry, this was not an F1 situation. By the way, if you press F1, it will bring you to our online documentation. So it's not necessarily a bad thing. So if you want to know a bit more about certain feature, the documentation is a good place to start. So if I open the first one, select curve, I'm going to select this one. I don't want to start from there to there. So if I want to go the other way around, just have to right click on the path and click reverse direction. I'm going to click done. I can click update. I have the green check mark. I'm gonna do the same thing with the other one here, from 1 to 2. Perfect. Update. Doing the same thing for the third one here. Now I want to start from the middle for this one, so I'm gonna go a bit closer. Reverse direction. Update. So this is perfect. Click done. Update. No, I should have the other way around. So my bad on this one. And then update. Okay, perfect. Here I can again go and select curve, just like that. Okay, I'm so sorry. I'm not in the right So okay, done here. So I was in the third again, so I do not want, so I can, if I selected a curve that I don't need, I can right click on it and then deselect, click done, and now I need to open the fourth one and select the last curve just like that, and reverse sense, click done. Okay, perfect. So now I have all the paths created. I can run them in a main program. Don't need to display the path here. Can run that while I'm closing all these windows. So this is great. This is great. This is following the path as expected. There's a lot of like wrist movement in this one, so maybe changing the orientation, the actual mechanical orientation of the tool could be a great idea. Okay, so this is all great, but I think that, let's say, the joint here with the approach and retract movements are a bit, let's say, brutal. So we're going by default directly with a approach movement or retract movement that is normal to the path. Maybe we can do something a bit better. So if I open the dispensing one or the curve follow project here, you can see by default you have normal approach and retract movements that were created. You can change the values obviously, and you also have access to quite a fair, quite a big, let's say, different options. You can either go normal, tangent, XYZ, with insert an arc with different rotation in them. It would have been a bit difficult to show you that, show you guys exactly how it works from this example. So I created another example here with all those robots that I'm gonna run all at the same times. So here this is the default parameter, so it's simply normal to the actual path I'm following. I can use the tangent one, so just tangent to the path I'm following. I can just go directly on the side. I can create arc like this, but arc that are not modifying the actual orientation of the tool. I can create arc that goes on the side instead of going upward or downwards. I can create arc that do change the orientation along the path, and I can create XYZ position, so this is just an XYZ position. And last but not least, I can chain up different approach and retract movements. So this one is chain one, so you can see here that I have an arc and a normal, one after the other, and same thing here, an arc with a normal. And for the last example here, I've went a bit more funky, and I have a bit more approach and retract movement chained together. Okay, so this is it. So let's go back to our example. If I want to add approach and retract movement like this, the only thing I need to do, let's say I'm going to go for dispensing one. This is the approach movement. So I'm going to create an arc normal, just like that. So this is perfect. You have the diameter of the circle, and the 60-degree here is pretty much like the size of the piece of pie you will actually take on the whole circle. And I can add a normal, let's say 50 like this, update, and I'm going to do the same thing here with this one. So normal, this is perfect, add 50, let's update, so I can simulate this here. As you can see here, there's really an arc that is created before entering the path. So this could be very useful if you're doing, so this can be useful here, but it can also be useful if you're doing like you're cutting, let's say your car is cutting fabric and you need to have a certain arc to like start grabbing on the fabric and start cutting it. So this can be a great way to do so. Okay, next example. So we are, yeah, things are going well, perfect. So next example here, we're going back to the first example. So I have two dispensing project that have no curve selected. So if I just come here, select curve, here, small detail, as you can see here, this curve is not joined together. There's places where I do not have any curve. This is not a big deal. So I'm going to select this here, reverse. If you have a lot of lines to select, you can either auto-select next or auto-select all. So that will auto-select all the curves that are tangent to the curve you just selected. I can click update and then simulate right here. As you can see, it didn't do any cases with the fact that I had some gaps in my curve. But this is because I have some special parameter here, join curve tolerance. So by default, I think it's 0.001 or something like that. If you have that, you will see here that it will create approach and retract movements every time you have a gap. You could just here remove here approach and retract at each curve and it will do the exact same thing. But personally, I prefer just giving a bigger number here. Yeah. Okay, so this is a thing. The other thing that I wanted to show you here, let's just do the exact same thing for the other one here. So select this, reverse direction, auto-select all, click done, update, and then simulate. Okay, update and then simulate. Okay, now let's talk about how you integrate that to your actual robot project. So I'm not going to go into like the super deep details, but you're going to need to figure out where this path is, or where this part is actually in the real station. So you have options here or tools here that are define tool frame or define TCP and define reference frame. So the key to position this in the virtual station in the same at the same position as it is in the real world. So the key to do so is exactly here. It's quite detailed in the online documentation, so I would recommend you to take a look. So this is the first thing you'll need to do to integrate this path created by RoboDK inside of the real robot controller. Afterwards, you may need to activate IO or subroutine at certain specific moment of the path. So if I open the path one here, you can click here on Program Events. Program Events will give you access to this here. So if you're not doing a machining project, this column doesn't really matter much for you. First thing you can do is modify the speed of the approach and retract movement. So let's say I'm going to go for 200. Oh, sorry, I'm going to go for 200. Here you need to set rounding. By default, it should be checked. Set rounding will help you having continuous movement and not just stopping at every single point. Then in the right column, you have you can add a like subroutine or event at certain moment of the path. So in this case here, I want the gun. So as you can see, as you've seen in this simulation here, the blue little dots showcasing that we were dispensing glue or sealant was not showing. This is because we didn't call the subroutine. So to call the subroutine, I want to call it when the path start, and I want to call it back when the path finish. So I can go here and say gun start, as it's the name of this macro here, and gun end. Perfect. And let's say here I have a go home subroutine that I created. I can just make sure that before the program I go home, and after the program I go home. Click OK. if I update and then simulate, now the blue lines appears, the blue dots, sorry. And at the end of the program, it should go back to home. Perfect. So I can do the exact same thing here, param event, path start, path finish. This is gonna be gun end, and then this is gonna be gun start. Update and then simulate, just like that. Oops. Update and then simulate. Yeah, sometimes this little macro needs a second shot, let's say. Okay, so once you have this, you will like to export that to the actual robot. So you have your two programs that were created. If you right click on them, you can generate the robot program here. And you will have access to all the points you need to reach. Important note here, remember we called the go home and gun start subroutine. They were called there also. So the goal for you, if to facilitate your integration, is to create those subroutines directly inside your robot controller. So the subroutine, let's say for gun start, could be just an IO that you can activate. So yeah, this way you will be able to launch the sequence that lets you start the dispensing process and then follow the path, and then at the end this process like that. You could have also had simply added an output that to be activated right there. Okay, and one last thing I need to show you. You can easily switch from one robot to the other once you have a station like this created. So let's say that this path here can run with this robot, and this path with this one here. So this is perfect. But let's say that I want to try other robots because I'm not so sure which robot I'm going to choose actually. So I can, oops, maybe I went a bit fast. So I can right click, replace program, replace robot, sorry. I created the list here. So I can go for an ABB. I can select both programs. I can just like update them. And the second one run. Okay, perfect. Now the first one didn't run, so we're gonna try to understand why it's the case. Just gonna press escape to stop the blue dots. So I'm gonna simulate, and we'll see where this path is stopping and why. So it's stopping here. If I double click the robot, I will see the robot panel. I'm gonna move myself a bit. And from this robot panel, you can now see that the problem is that joint 4, is reached its limit. Here, one important thing in the curve follow project is that you have preferred joint for start point, and you have all the configuration you can start with. So right now, our joint 4 reached is lower limit. And as you can see here, we started with a joint 4 at minus 245, which doesn't give us a lot of room. So if I just use my scroll wheel and rotate from one here, I can select between the different configuration available. I can update here. And with this new configuration, I'm able to follow the path up until the end of it. Perfect. Now that I have this, before I was able to create src file for the KUKA robot, now I can just like right click and generate robot program. This is an ABB, so it will create a .mud file. Or if I want to create something else, so replace robot, let's go for a Kawasaki. Let's just update those two programs. Yeah, I'm gonna need to just rotate the base here just like that. Okay, perfect. Just gonna update those programs, see what's going on. Simulate here. So again, the problem is a limit around joint 4. So if I can have another option here, so this one works, perfect. Usually it would select the best option, but considering that we're like replacing the route is starting from the parameters it had before, and now I can close this. I can right click and generate route program, and now we have a program for the Kawasaki robot. I could like continue the same concept here, replace robot, and go for a fanic. The base of a fanic is not positioned at the same place, so I need to just, and again I can re-update both here, switch to another configuration, switch to another configuration. Both programs are now doable, just like that, following the path just like that. I can right click, generate robot program, and I'm generating the ls file that can also be compiled to have a TP file afterwards. Okay, so the only section of the curve follower project I didn't talk about was the optimization parameters. So the optimization parameters are there to help you avoid singularities, joint limits, and other. So they are really helpful, but we will talk about that in the next webinar. Okay, so before jumping to the question period, I have a few things that I want to show you. First of all, I told you that I was about to give you the link to download the different example I just showed you. So the link is pretty simple. So you go robodk.com/w. You will reach this here. So this is a shortcut for Files Webinar. You will reach all webinars, and here in the webinar 4 CAD to PAT part 2, you have all the example I just shown. So this is super helpful if you want to learn a bit more. Another thing, if you go on our website, you go in resources, you can have access to the robot library. You can also have access to the documentation and the forum. So if you have any questions, I would recommend you to take a look at the documentation. And if you don't find the answer you're looking for, you can reach us through the RoboDK forum. So this is the online documentation. I would like to bring your attention to two different sections. So the general tip here, define TCP, define reference frame. This is what I was talking about if you want to position properly the object and the path inside RoboDK, so when you export the path, it's actually at the right position. And the other section I would like you to take a look at is the robot tips. So depending on the robot manufacturer you plan on using, there's different, let's say, features or particularity to those robot. And last thing, like I said, if you have any questions, feel free to visit our forum. We are answering quite fast usually. Perfect. So that's pretty much everything. Thanks guys. I'll start answering your questions. Okay, that's pretty much everything for today's webinar. If you think it was helpful, please hit that like button and subscribe to our channel. We will release more of those in the future. You really don't want to miss any of this. And remember, if you have any technical questions, you can reach us via the forum, so www.robodk.com/forum. We'll be happy to help you with your project. Have a great day.